At -67 degrees Fahrenheit, exposed skin freezes in seconds, and even elite climbers die within half an hour. Yet monks on these same Himalayan ridges sit nearly naked, wrapped in wet sheets, and emit so much heat that steam billows around them, seemingly breaking the fundamental rules of human biology. Is it myth, lost science, or something beyond the textbooks? The human furnace begins with a single, burning question. How do they do it, while never moving at all? The air at -67 degrees Fahrenheit feels thick, almost sticky, clinging to any exposed skin. Moisture in the nostrils freezes solid on the first breath. In these conditions, the human body faces a deadline. Within minutes, the cold strips heat from the skin, pulling warmth away from blood vessels and driving it toward the core. The first response is shivering, a desperate attempt to generate heat through muscle contractions. But at this temperature, shivering is only a brief defense. Core temperature begins to slide. Once it dips below 95 degrees Fahrenheit, the body's systems start to falter. Hands lose dexterity as blood retreats, fingers stiffen, and confusion seeps in. Thought becomes sluggish, muscles grow weak, speech slurs. If nothing changes, the drop continues. Below 90 degrees Fahrenheit, the heart struggles to keep rhythm. Below 86 degrees Fahrenheit, shivering stops entirely, replaced by a false sense of warmth and a dangerous calm. In the final stages, the mind drifts and the body slips into a lethargic sleep, sometimes mistaken for peace. Death from exposure in these extremes can come in less than 30 minutes, even for the strongest climbers armed with layers of gear. For someone sitting motionless with nothing but a thin cloth or a wet sheet, the outcome should be certain. The laws of biology seem absolute. In this cold, the body cannot save itself. The only way to survive is to find shelter, move, or add heat, unless there is a way to rewrite the rules from within. A deep inhale fills the lungs, the chest expanding as if to drink in the cold itself. The monk's breath is slow, deliberate, and impossibly calm. Instead of gasping or shivering, he draws the air down, forcing it into the belly. The next step is almost invisible. The abdomen contracts and holds, turning the lower belly into a pressurized vessel. This is vase breathing, kumbhaka, where the body becomes a sealed pot, trapping warmth at its core. On the outside, the world is frozen and still. Inside, a silent engine begins to turn. In a typical cold shock, the body's first instinct is to pant, taking quick, shallow breaths that only make things worse. Panic breathing strips away carbon dioxide, narrowing blood vessels and starving the body of oxygen. But in vase breathing, everything reverses. The breath is held, the pressure builds, and the mind stays focused. Scientists studying these monks have traced subtle changes in the nervous system during this phase. The long pressurized hold stimulates the vagus nerve, a highway connecting the brain to the heart, lungs, and gut. This signal shifts the body from a state of alarm to one of deep rest, even as the cold rages outside. The pressure inside the chest rises, forcing more oxygen into the blood with every cycle. This is not just about staying calm. The process primes the body for what comes next, a controlled ignition of internal heat. In field studies, neuroscientists have measured how this breathing pattern alters heart rhythms and skin temperature, showing that the monk's body is not surrendering to the cold. It is preparing to burn. Each breath is a choice, a precise act of survival that sets the stage for the body's hidden furnace to spark. Heat begins in an unexpected place. Under the skin, just above the collarbones and along the spine, sits a layer of tissue most adults never notice, brown adipose tissue or BAT. Unlike ordinary body fat, which stores energy, BAT acts as a biological furnace. Its cells are packed with mitochondria, each loaded with iron and a unique protein called UCP1. When activated, these mitochondria break the usual rules of biology. Instead of turning calories into usable energy, they burn fuel just to make heat, releasing warmth directly into the bloodstream. For most people, BAT only flickers to life in childhood or during sudden cold exposure. In the monk's practice, the ignition is deliberate. The deep, pressurized breathwork triggers a burst of norepinephrine, a stress hormone that signals BAT to uncouple its mitochondria. The result is a prickling surge of warmth, often described as a wave radiating from the neck and upper back. This sensation is not a side effect. It is the body's main defense against the cold. Scientists have traced this thermogenic pathway in laboratory studies, confirming that norepinephrine can activate BAT and increase heat output without shivering. No direct imaging has captured this process during G-Tomo meditation, but the physiological fingerprint matches what is known from other cold-adapted humans. The heat generated here is not scattered randomly. It is produced at the core and must be moved outward, setting the stage for the next challenge, keeping the skin and extremities warm without losing control of the body's precious energy reserves. Fingers exposed to deep cold usually turn pale, then white, as blood flow shuts down to protect vital organs. This is the body's hunter's response, a built-in reflex that sacrifices the skin and extremities to keep the core alive. In these conditions, capillaries in the hands and feet clamp shut, cutting off circulation. The skin grows numb, waxy, and brittle. Within minutes, frost nip sets in. If the cold continues, tissue freezes and dies. Yet, during G-Tomo meditation, something different happens. Field studies from the Harvard expedition recorded monks' fingers and toes rising by as much as 17 degrees Fahrenheit above baseline, even in rooms chilled to 40 degrees Fahrenheit. Instead of retreating, blood flows freely to the skin. The monks' hands remain pink and warm, nimble enough to handle wet sheets or hold a mudra. This visible contrast, one person's fingers white and lifeless, the other's flushed and supple, signals a reversal of the usual rules. The mechanism is called neurogenic vasodilation. Through practiced control, the monk's nervous system instructs the smooth muscles lining the arteries to relax rather than constrict. Blood, rich with newly generated heat from the core, is pumped outward to the skin's surface. This seems counterintuitive. In most cases, sending heat to the periphery would mean losing it to the environment and risking hypothermia. But for the monk, the internal furnace burns so hot that this outward flow is not a liability. It is essential. By keeping the skin perfused, they prevent frostbite and allow excess heat to escape safely, much like a high-performance engine that requires constant cooling. The ability to override this ancient reflex is not a trick of willpower, but a demonstration of conscious vascular command, measured in temperature probes and visible in the color of living flesh. Legs cross, ankles resting high on opposite thighs, knees pressed flat to the ground. The monk settles into Padmasana, full lotus. The spine rises, vertebrae stacked in a single unbroken line. Shoulders drop, jaw unclenches. This posture is more than tradition or display. It is a structural lock, a living equation in bone and muscle. In the cold, most people curl inward, hugging their knees, trying to make themselves small. But this instinct collapses the chest, squeezing the lungs and reducing the power of each breath. The lotus position does the opposite. By folding the legs and tucking the feet, the surface area of exposed skin drops sharply. The thighs and shins shield one another, and the feet are hidden in the warmth of the lap. Blood flow to the legs is gently restricted, not cut off, but slowed, so heat stays where it's needed most: the core, the lungs, the brain. The upright spine acts as a conduit, keeping the airway open and the diaphragm free to move. There is no tension in the limbs. The body balances on 3 points: the knees and the base of the spine, forming a stable tripod. Once settled, the muscles can relax completely. No energy is wasted on holding the pose. Every calorie, every shred of metabolic heat is available for the work of survival. Mathematically, this position minimizes the surface area to volume ratio, reducing the body's exposure to the freezing air. The geometry is ancient, but its logic is precise: conserve heat, maintain stability, and prepare the body for the next phase when the mind itself becomes the ignition switch. A single image drives the next phase of this practice: a flame, small and brilliant, burning at the navel's center. Every inhale, every held breath feeds it. The monk's attention narrows to this point, tracing the imagined heat as it rises through the body's central channel, a pathway described in centuries-old texts. This is not a vague daydream or wishful thinking. The visualization is disciplined, repeated with unwavering focus until the mind and body respond as if the fire were real. Modern neuroimaging has begun to map what happens in these moments. As the monk concentrates on the navel flame, the sensory cortex, the region of the brain that registers touch, warmth, and pain, lights up. The body's internal thermostat, usually governed by the hypothalamus, receives new instructions. The brainstem, responsible for basic survival reflexes, is coaxed into believing the body is surrounded by heat, not cold. This effect is so strong that the body sometimes initiates a cooling response, vasodilation, even sweating, despite the freezing air. For most people, trying not to feel cold only sharpens the discomfort. Psychologists call this the ironic process theory. The harder you push away a sensation, the stronger it returns. The monk's method sidesteps this trap entirely. By focusing on the vivid, sensory-rich image of fire, the mind's energy is channeled into a physiological outcome. The boundary between imagination and reality blurs, and the body begins to act on the mind's instructions. This is not placebo in the usual sense. It is a deliberate, repeatable act of self-regulation, confirmed by brain scans that show the cortex and brainstem working in tandem. The result is a mind-body link that crowns the suite of controls leading up to the public test of the wet sheet challenge. A physiologist stands in the cold, notebook in hand, watching as an attendant dips a cotton sheet into a bucket of icy water. The sheet, heavy and dripping, is draped over a monk's bare shoulders. Water beads on the skin, then begins to freeze at the edges. In standard conditions, a wet cloth against the body is an unforgiving test. Water conducts heat away from skin about 25 times faster than air. For a typical person at rest, this means the body loses warmth at a rate that quickly overwhelms its ability to compensate. The numbers are stark. To evaporate just 1 kilogram of water from a sheet at freezing temperature, the body must supply 2,260 kilojoules of energy. That is enough to power a 600-watt space heater for an hour. The sheet clings to the monk, yet he sits unmoving. Within minutes, steam rises in visible plumes, swirling in the frigid air. The sheet, once sodden and cold, begins to dry. Over the course of an hour, the entire kilogram of water vanishes as vapor. The calculation is simple but astonishing. 2,260 kilojoules divided by 3,600 seconds is roughly 628 watts of continuous thermal output, more than most household radiators. There are no hidden wires, no external heat source. Every joule comes from within the monk's own metabolism. The physiologist checks the ambient temperature, notes the humidity, and confirms the constants: the latent heat of vaporization for water at 0 degrees Celsius, the thermal conductivity differences between air and water, and the absence of shivering or muscle activity. The evidence is plain. The monk's body is not just resisting the cold. It is producing enough heat to dry a wet sheet in a sub-freezing room, a feat that defies ordinary human physiology. The numbers challenge any easy explanation and demand a closer look at what is happening inside the body and brain. A Himalayan guide once described the energy in the meditation chamber as electric, more like the hum of a high-tension wire than the drowsy calm of ordinary meditation. The monks' bodies remain still, but inside, every system is running hot. Heart rate monitors show a paradox. The pulse surges, sometimes reaching levels seen in light exercise, while the breath stays slow and deep. This is not relaxation. It is a controlled storm, where the nervous system's two halves, sympathetic and parasympathetic, are switched on together. Normally, these systems act like rivals. The sympathetic branch fires up in emergencies, raising heart rate and pumping out adrenaline, while the parasympathetic calms and restores. In G-Tummo, both are active at once, a rare state that scientists call co-activation. The body is alert, ready for action, yet the mind is settled and focused. EEG recordings taken during forceful vase breathing reveal a surge in gamma brainwaves, rhythms above 40 Hz, linked to moments of insight and peak concentration. These waves do not just flicker, they dominate, forming a synchrony across regions of the brain. Sustaining gamma activity at this level is metabolically expensive. Glucose consumption rises, feeding the neural circuits that keep awareness razor-sharp. In lab studies, monks maintain this state for minutes at a time, their brain activity resembling the patterns seen in elite athletes at the height of performance. Heart rate variability, a marker of nervous system flexibility, shows wide swings, evidence of rapid voluntary control over physiological arousal. The result is a kind of internal ignition. The body burns hotter, the mind stays clear, and the cold becomes just another sensation to be managed. This peak state, measured in electrical signals and chemical markers, is as much a product of training as any feat of endurance on the mountain. The guide, watching from the edge of the room, notes that even the most experienced climbers rarely show this kind of balance, alert but unafraid, every cell tuned to the demands of the environment. Inside the meditation hall, the final barrier is not physical, but psychological. The cold remains, pressing in from every side, but the monk's attention moves inward. In interviews, practitioners describe a shift. The sensation of cold is no longer personal. It is not, "I am cold," but simply, "there is cold." This subtle change is more than wordplay. In the Tibetan tradition, pain and discomfort are not denied, but observed. The equation is simple: suffering equals pain multiplied by resistance. The cold itself is real, but the struggle against it, tensing, fearing, wishing it away, amplifies the distress. By dropping the resistance, the sensation loses its power to harm. A senior monk once explained, "If you fight the cold, it wins. If you witness it, it passes through you." This approach is rooted in centuries of Buddhist psychology, where the dissolution of self is the ultimate protection. The practitioner's sense of identity dissolves into the act of meditation. There is no ego left to defend, no boundary for the cold to breach. What remains is pure awareness, steady and untroubled, even as the body sits exposed to the elements. Yet this is not a call for bravado. The monks are clear. These practices are not a test of toughness or a shortcut to superhuman feats. Years of preparation, mentorship, and gradual exposure are essential. Attempting to replicate such meditations without guidance is dangerous and can lead to hypothermia, injury, or worse. The mind's role in survival is profound, but it does not grant immunity from the laws of nature. In the end, the lesson is not about conquering the environment, but about changing the relationship to it. The cold becomes energy to be observed, not an enemy to be fought. Even as scientists debate the limits of human physiology, the practice of G-Tummo stands as living evidence that mind and body are not fixed boundaries. In a world facing rising stress and environmental extremes, this tradition reminds us the frontier of resilience is not just genetic, but deeply trainable. The next breakthrough in human potential may begin with a single, conscious breath. What do you think? Could you light your own inner fire?